This is rule number 1 for table. This rule is what should be the sequence of columns. Actually, the first column is not counted. We call it zeroth column. Zeroth column, that's the we denote by serial number. Now it's up to you whether you write this or not. That's why I'm calling it the zeroth column. It's up to you whether you include it or not. Examiners don't mind it if you include, but it's better to include because then you are always on your toes that how many readings you have taken. You are always actually you get in a well manner with the time management. You can manage the timing. So first, this is the zeroth column. First column is always of independent variable. Second column, and it has 3 subcolumns. That is always of dependent variable. And in physics table, we usually not calculate the things directly. Each thing is calculated independently. So after that, there will be many columns. Second, it can be third, fourth, or as the case may be, columns. They will be of the quantities involving dependent variable. Quantities involving dependent variable. You can third or fourth column. When you finish with the quantities involving dependent variable, then the column whatever can be supposed fifth, sixth, whatever the columns. After that, whatever the column number there will be, you will go for the quantities involving independent variable. Quantities involving independent variable. So then in the end you always have what then columns comes involving both dependent and independent. So this is the sequence of columns. Now I'll explain it. Always the last column is always told by the examiners. Examiners tell us that which should be the last column. For example, suppose in simple pendulums practical, it cannot be real things, but I'm just giving an example just to want to make you clear how the column sequence of the columns must be. Now actually in the case of the simple pendulum, so the length of the simple pendulum L, and you swing it like this one for 20 times 20t, time for 20 oscillation I have already explained. Time for 20 oscillation, this is O to A to O, then A to B, then B to O again. This is one oscillation, and you have to note time for 20 oscillations. And in the end, suppose examiner says you have to record the value of L square upon T square. He says, for example, how will you make the column headings? Actually, each column must have a unit, but I'm not talking about the unit here because that's my second rule. So how I will make the sequence of the columns without units? This must be, this is serial number 0th column. Then first column is the independent variable, which is length. I will write length, and if I take in meters, I will write meters, millimeters, whatever. Then this is the second column. Now the reading of the dependent variable always repeated, So this one I will have 3 sub columns, one reading, first reading, second reading, average. This is 20t. 20t means time for 20 oscillations. I will write here T1, T2 and this is the T average. Or if you wish, you can write here 20 T1, 20 T2 and this is the 20 T average. You can write also this way. Both are right. Then I have to go for 1 upon t square, but 1 upon t square I cannot calculate directly, so I will be calculating t square. You are not allowed to calculate directly t square. First you will calculate t, you will obtain t by just dividing this by 20, then you will obtain t square, because you have to finish with all the, see this is the independent, this is 0th column, independent variable, dependent variable and 3 sub columns, then quantities involving dependent variable, then I have finished the dependent variable, then L square comes. I cannot calculate directly L square upon t square. First I will be calculating L square, quantities involving independent variable, then quantities involving both. So this is the sequence. So the rule is very much clear. First 0th column, then independent variable, then dependent variable, and if it is repeated then it's 3 sub columns, then quantities involving dependent variable, then quantities involving independent variable, and then quantities involving both. So that is rule number 1, and that is about the sequence of columns. Now rule number 2 is about the units. Rule number 2 for table is about the units. Let us see how the units are taken. Rule number 2 is for units. How the units are taken? Actually, each column heading must have a unit. Prefixes and powers of 10 can be in the heading with units. Can be in the heading with the units. Second thing is, no unit should be in the content of the tables. And third thing is, no 2 slashes are allowed. No 2 slashes or solidus notation allowed. Allowed for units. So actually for rule number 2 we have to demonstrate this A part, B, C and D. These are the subparts of this rule. It says that each column heading must have a unit. Prefixes and powers of 10 can be in the heading with units. No unit should be in the content of the table, and no 2 slashes or solidus notations are allowed for units. Now let us see how we write the units usually and what the students make mistakes. Actually various notations are allowed. For example, if I make the length, if it is made in meters, I can write LM, or I can write also this. Both are correct. Or I can write also in this one meters. But this must be discouraged. This must be discouraged. Although it is correct, but it must be discouraged. Or this is also allowed in L in meter. This is also allowed all L in meters. These are also allowed, but these 3 must be discouraged. So it is better to write in this way. Suppose L in millimeters, you can write L millimeters this way, L millimeters in this way, or even you can write this way 10 power minus 3 meters, or L 10 power minus 3 meters. This is the exponential of this one. Now it is better to always give the exponent first, then the unit, or the prefix first, then the unit. Although it's not wrong if you give this 10 power minus, if you give in this way, it's not also wrong. In old time this was the usual common customary to write this, but nowadays it is better to write in this way. So this is the better way. Now suppose if you have L in centimeters, you can write L in centimeters, L centimeters, L 10 power minus 2 meters, or you can write L 10 power minus 2 meters. Suppose something is 10 power V 10, suppose I will write, suppose it is, the value is 2.5 into 10 power, suppose 5, something comes. So suppose I will be writing, suppose 2.5 into 10 power 5 is coming. So I will be just writing any quantity, put the 10 power 5 and the proper unit here, then I'll just writing here 2.5. So this is the way how the powers of 10 will be entertained in the table. In this way you can write those units. So the better thing I will advise this or this. Follow these two, L bracket M or L slash M or L cm or L 10 power minus 2m or L oblique cm or L oblique millimeters or L mm or L 10 power minus 3 meters, and in any case this is the, for L. For example, now if the units are in compound notation or so many quantities are involved, suppose I have to write the unit of, suppose L upon T. I will write the unit in this way, meters per second. This is allowed, or L select this 8 and write down meter per second. These both are allowed. But if you write in this way, this is rubbish, 3 slashes. Or if you write in this way, 2 slashes are not allowed. So that's wrong. You can write in this way, either L upon T, you can write meters per second, or L. You see, this is a horizontal line, L upon T, and you can write meter s power minus 1. But this bracket must be appearing in the numerator, not in the denominator. So L upon T. Suppose if I have to write, or you can write in this L T power minus 1, write M s power minus 1, or L T power minus 1 slash M s power minus 1. These are usually this rule is very much essential and very much used when the current is given and you have to calculate the value of 1 upon I. Usually current I comes in milliamperes made by this one, and suppose it is coming 6.52 milliamperes. Then I will write 1 upon I, 1 upon I, see 1 upon I, this is the correct way, and express in ampere, that will be better. But when you express, when you calculate this, just calculate in this way, 1 upon 6.52 into 10 power minus 3, and then calculate, write 1 upon I. But if you can write in this way also, per ampere, this way. But if you write in this way, 1 upon I ampere, that's wrong. Or if you write 1 upon in this way, 1 upon I per milliampere or minus 1, that's wrong also. 2 slashes are not allowed, but milliamperes you can have like this one. This is okay. This is also okay if you calculate milliampere, but then the calculations involves, it becomes so many complicated while drawing the graph and other things. So I advise for 1 upon I, and that is the very common mistake these students do. I have seen over the years, they do not calculate properly 1 upon I when they record I in milliamperes. Suppose I am just doing an example. Suppose I in milliamperes is 62.6 in 1 decimal place. The instrument was accurate. Suppose then I will calculate 1 upon I in amperes like this one. I will write 1 upon 62.6 into 10 power minus 3 and use the calculator. I'll use the calculator. 1 divided by 62.6 exponential minus 3. It is coming 15.97. I have to, so this is a 3 significant figure, so I'll write it in 3 or 4. So I'll write 15.97. I can write it 16.0, this one. I'll write 16.0, or if I wish I can write 15.97 also, because I can I will talk about the significant figures later on, but I can calculate in this way. So that is the better way for calculating this one. Now suppose in the previous case, when I was to suppose include the units, how the units will look like. If, initially we will be, it is always, I will advise you always take the SI unit, not the prefixes, unless it is asked to you. So suppose I'll say first serial number, I will take L in meters, this 20t oblique seconds, then no need to write here, this is T1, T2, T average. If you wish, you can write this 20T1, 20T2 and 20T average, but no units are required because these are the subheading, sub-columns of this one. So 20T, then I will write T in seconds. See, each column heading has a unit, and then I will write T square in second square, then write suppose L square in meter square, and this is suppose L square upon T square, I will write it's meter square S power -2. So this is the rule number 2 for the tables. So rule number 1 is for the sequence of the columns. Sequence of the columns must be first the zeroth column, which is called the zeroth column serial number. That first column is always independent variable, second is dependent variable and its 3 sub columns, then quantities involving dependent variable, then quantities involving independent variable, and then quantities involving both. And rule number 2 is for the units. Each column heading must have a unit. I tell you, if there are the units written in the table, then you cannot write in this one. For example, suppose this is the case 0.200 meters. If meters here, I cannot write it a meter. This actually happens when theta is in degrees. When theta is degrees, and usually you should write 60 degree, 30 degree, that's wrong, because once you have included degree in units, you cannot repeat it. So, and other thing is, always try to write in brackets and or slash m or whatever the case is, slash seconds, bracket seconds, and always use the exponent notation. Suppose meter per second, meter square per second square per ampere, whatever the case. Do not use the 2 slashes and use the horizontal line. For example, I have seen this must be a horizontal line, L square upon T square, M square, S power -2. This must be a horizontal line. This must be a horizontal line because 2 slashes are not allowed. So these are the 2 rules for this one.